Welcome to today's class. Today's class is current electricity in physics higher secondary second year, and it is class number 2. I have done class number 1 earlier. So please go to the first class, otherwise you can't understand the second part of the electricity. It starts from relaxation time. So before explaining what is relaxation time, it is denoted by tau. Relaxation time is related to the motion of or collision of the electron in a conductor. That in the last class I told you that in a conductor there are free electrons, and free electrons always moves without any electric field because of thermal temperature. Am I right? And also I mentioned that when electric field is, when the potential difference across the two ends of the conductor is applied, then electric field is produced. And when the electric field is produced, the electron starts moving, and during the moving there are fixed charge, positive charge in the conductors, they collide. So there is two kind of the velocities after the collision, velocities before the collision. Means there occurs collision between the electron and fixed charge, fixed bigger charge of the plus charge of the conductor. And now what is relaxation time? Relaxation time so we can define relaxation time, that is the electrons when moves collide with each other, or the fixed positive charges, and that is we can define that the relaxation time is the time interval between two successive collisions of electrons with fixed positive ions in a metallic crystal, which is called relaxation time. And relaxation time is represented by tau, that is tau is equal to mean free path divided by RMS velocity. You have got this RMS velocity and mean free path in the chemistry, you please go through this one. Mean free path is designated as lambda, it is a distance, and RMS velocity is equal to VRMS. So relaxation time mathematically can be written as tau is equal to lambda by VRMS. Again, VRMS is directly proportional to temperature. If temperature increases, so VRMS increases, and if VRMS increases, tau will decrease. So tau decreases with increase in temperature. So this is the relation between tau and temperature after getting the mathematical expression. This is all about relaxation time. Next part is mobility. What is mobility? Mobility is designated as mu, and it is so mu is the mobility of the electrons. Mu is equal to Vd by E, where Vd is equal to dip velocity. I have already mentioned in the first class of current electricity, and E is the electric field, also it is known to you, also I have explained these things. So mobility is nothing but the dip velocity of electron per unit electric field. Dip velocity of the electron per unit electric field. So what is Ohm's law? And very often you have got in higher secondary in metric class also. In details we will go through this point, Ohm's law, because a lot of questions are very often asked in entrance exam, also in the board exam. So what is Ohm's law? If the physical condition, very often you miss this part. Whenever you are asked to write the definition in the board exam, you should mention this. If the physical condition of a conductor, what is physical condition? Means temperature, length, or mechanical strain of the conductor should be fixed or remain same. At this condition, the current I through the conductor is proportional to the potential difference across its two ends. That is B is directly proportional to I, or B equal to some constant R into I, or R is a constant called resistance. This is Ohm's law. V is equal to IR. If you draw the graph B and I, the nature of the graphs will be in this way. It is a straight line B and I, and if you take the graph in two different temperature T1 and T2, where T1 is greater than T2 and T is directly proportional to the R. So T1 is greater than T2 means R1 is greater than T2 means resistance is greater than T2. At this condition we get the two graph at temperature T1 and T2 in velocity versus I is like this. Let us see on what factors a resistance depends. What is resistance actually is, again it is known to you, the property by virtue of which it opposes the flow of the electron in a conductor is called its resistance. The property by virtue of which the flow of electron is dragged out, is opposes, is slowed down. This property of the conductor is called resistance. So resistance specially depends upon two factors. One is length of the conductor, other is area of the cross section. So if you assume L is the length of the conductor, A is the area of cross sections of the conductor, N is the number of electron per unit volume, and tau is the relaxation time, and M is the mass of the electron. I have not written it, is known to you, it is implied. Then we can write R is equal to proportional to L and R is proportional to 1 by A, means in combined variation R is equal to, if you combine these two, R is proportional to L by A. When you remove this proportionality sign, the constant here is rho. We have assumed rho. So R is equal to rho L by A. So this is the resistance. R is equal to rho L by A, where the value of rho is this, m square n square tau. M square n square tau. Tau is the relaxation time. We have already mentioned as the number of electron per unit volume equal to the charge and equal to mass of the electron. Then the relation of R becomes R is equal to m square n square tau into L by A. So if please keep it in your mind, very often in entrance exam a lot of questions asked from this. Here R equal to resistance and rho is called resistivity and L is equal to so R equal to resistance equal to rho L by A. Bit earlier we have shown it, and resistance equal to rho L by N, where this rho is the constant rho, you have assumed rho is the constant, this rho is called resistivity. And we can say R is equal to rho L by A. What is rho? Resistivity is equal to RA by L. So now from this what we get? If so now from this we can see that if length of the conductor is equal to unit, that is 1 meter if you assume, and area is equal to 1 meter square unit length, if you assume the unit length, So this will become 1 and this will become 1, then R is equal to rho, means resistance equal to resistivity. So on this condition you can define that resistance is numerically, R is numerically equal to the resistivity of a conductor having length 1 meter or unit, and area of cross section of the conductor is equal to 1 meter square or unit square. Now what is conductivity? Again you have got it in second year chemistry also. The conductivity sigma is equal to 1 by rho. It is reciprocal of resistivity. So the conductivity which is designated as sigma, sigma is equal to 1 by rho, or it is the reciprocal of resistivity. Less the resistivity, more is the conductivity. Again, I am not elaborating the fact, since I have also already mentioned in the higher secondary second year in chemistry, the conductance. The conductance equal to 1 by resistance. It is the reciprocal of resistance. Less the resistance, more is the conductivity. If you want to find the unit of this, conductivity equal to 1 by ohm or ohm inverse or Siemens. Again, it is known to you. So conductivity is designated by C. C is equal to 1 by rho. 1 by rho is equal to 1 by ohm. That is ohm inverse, or the unit is Siemens. So let us explain again grouping of the resistances. It is very simple. This is series connection and R series combination and parallel combination. If you assume the resistances R1, R2, R3 dot dot, a lot of resistance, if they are connected end to end, if these resistance are connected end to end, then these resistance are called series connection. This type of connection is called series connection. Say if it has a one value of resistance, second value of resistance and third value of resistance, what is the equivalent value of this resistance? It is given by equivalent value, equivalent resistance capital R. I have assumed this capital R is equal to R1 plus R2 by R3. That is, it says that from this we can see that the equivalent resistance is always greater than the maximum resistance of these two. Say it is 1 ohm, this is 2 ohm, this is 3 ohm. If you find the equivalent resistance, we will get the equivalent resistance is 3 to 5 and this 6. Total equivalent resistance of this combination is 6 ohm. And this 6 ohm is the highest of the individual 3. 1, 2, 3. Highest is 3. So the equivalent resistance in series connection, in combination, equivalent resistance is always greater than the highest value of the individual resistance connected in the series. Now if three resistors are connected in parallel situation, this is called parallel. In parallel combination, say this is R1, R2 and R3, this type of connection or combination is called the parallel combination of electron. In this type, then total equivalent resistance of this combination of parallel combination is called 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That is 1 by R. That is, if you want to find out that R will be equal to R1 by R1, R2, R3 divided by R1, R2, R2, R3 plus R3, R1. Am I right? So if you find out this value, if you assume the individual value 1 ohm, 2 ohm, 3 ohm in this way, if you find out the equivalent resistance in parallel connection, then this value of the equivalent resistance is less than the highest value of the three individual resistors. Oh. Now one of the important point here is mentioned is that if the two resistors say R1 and R2 are combined in parallel combination and current I is made to pass through this, and if you are asked what is the current in resistance R1 and what is the current in resistance R2, then the new current through resistance R1 will be I into, and the new current through resistance I2 is equal to I into you please keep it in mind, very important, very often question asked through, if whenever you are asked to find out the resistance through resistance R1, you keep the other resistance above and total is below and total current is this, and you are asked to find out the current through resistance R2, you keep the resistance R1 above and R1 and R2 below and total current is this. You please keep it in your mind. It is the shortcut way to find out the current in individual resistance connected in parallel. So the first very important point here, I am going to mention here, is the n identical resistance are connected. Resistor 1, 2, 3, 4, 5. These resistance are 1, 2, 3, 4, 5, 6 are first connected in series, and again the same resistance are connected in parallel combination. Whenever it is connected in series, its equivalent resistance is say Rs, and whenever the same n number of resistance are connected in parallel, say equivalent resistance equal to Rp. You are asked to find out the equivalent ratio of the equivalent resistance in these two combination, then Rs by Rp is equal to n square by n, where n is the number of the resistance in parallel connection, parallel combination, or in series combination. Say a long wire which has resistance R, and if this wire are cut into some equal length, equal parts, say 1, 2, 3, 4, 5, 6, 7, 8, I have made this wire into 8 equal parts, n is equal to 8. Then you are asked, if this 8 part, 1, 2, 3, 4, 5, 6, 7, 8, if this all are placed in a bundle fashion, and what will be the equivalent resistance of this bundle? Answer, R divided by n square. Just keep the formula in your mind, otherwise you can't answer in the exam. The third important point is that where you are given R1, R2, these are the two resistances which are connected in series, and you are given, its value is given, that equivalent resistance in series combination is given Rs. Again, same R1 and R2 are connected in parallel fashion, in parallel combination, and also the equivalent resistance of the same resistance in parallel combination is given Rs. Means equivalent resistance in series, equivalent resistance in parallel of two resistances are given, and you are asked to find out what is the value of these two resistances. Answer, R1 is equal to half into Rs, half into, inside the bracket, Rs plus root over Rs square minus 4 Rs Rp, and R2 is equal to half into Rs minus root over Rs square minus 4 Rs Rp. Only the sign is changed. The second bracket is, first bracket is the same. Then you can find out the individual resistance R1 and R2, whose equivalent resistance is the given resistance when it is in parallel, and these two individual resistance when in parallel combination, the value is given will be the same. So in this way, value of the individual resistance can be found out if their equivalent resistance in series and equivalent resistance in parallel is given. So this is one of the important fact I have here forgotten to mention, that in Ohm's law it is not a universal law. Ohm's law is not universal law. V is equal to IR. Ohm's law is not universal. Means in each and every substance this law is not valid. Very often in entrance exam or class exam you are asked in which case the Ohm's law is valid and in which substances it is not valid. In maximum cases, in maximum substance, Ohm's law is valid. The substance for which Ohm's law is valid is called ohmic substance. Ohmic substance. And substance for which the Ohm's law is not valid means V is not directly proportional to I is called non-ohmic substances. So especially here the Ohm's law is not valid for the substance when substance is here. Ohm's law is not valid, or the thermionic valve you will get later on. Ohm's law is valid, or the transistors. Ohm's law is also not valid for crystal rectifiers. So these are the substances in which the Ohm's law is not valid. Hence, Ohm's law is not an universal law. Next, color coding of resistance. What is color coding of resistance? That is, in certain resistance, some color band rings are there with different colors, and with the help of this color, we can calculate the resistance in ohm. Now, commercial resistance are of two types. One is so in a very simple way, just let me define the type of resistors. One type of resistors are wire bound resistors, when the resistance some wires are bound, and other resistors are carbon bound resistors. Wire bound resistors are generally alloys, made up from alloys, nichrome, constantan, etc. And this wire bound resistors has a very small range of resistance, varies from fraction of ohm to 100 ohm, very small range of resistance. But carbon resistors have wide range of resistance, and they are inexpensive. Hence, nowadays in domestic purpose, carbon resistors having wide range of resistance in ohm are used. Now, what is the main significance of color coding of resistance? Color coding resistance means with the help of color coding, color bond on color ring, we can measure the resistance, the value of resistance, we can calculate the magnitude of resistance. So let us first tell you how to find out this. In a very simple way, let me write one thing, you should keep it in your mind. The way how I have kept in my mind, you can also keep in this way. These things should be kept in your mind, otherwise you can't. To calculate the resistance with the help of ring, with the help of color band or color ring in the resistance, there are sometimes the resistors with different rings, resistors with rings having different color, red, blue, green, are used, and with the help of this uh, color, we can calculate the resistance of specific ring. I will show you the practically how to calculate, and just to keep it in your mind, BB Royce, say it is name of a person, BB Royce gave blow banished wrestler. He is banished a wrestler by giving a blow. Keep this in your mind. With the help of this, you can find out. BB Royce, B These different colors, which are in the form of ring or band, have different values. These colors have been given number, and these are significant figures. Significant figures. Multipliers, tolerance, or so For black B, the value is given, number is given 0, and I will explain multiplier is 10 to the power 0. And from this you write 1, 2, 3, 4, 5, 6, 7, 8. Sorry, here I have missed great wrestler. The line is BB Roy's, it is the same name, BB Roy's great blow banished great wrestler. So great wrestler, here there is G for gray, and white equal to W. So up to 0, 1, 2, 3, the number is given from black to white. Am I right? So from this phrase, from this line, you can BB Roy's great blow banished great wrestler. You can write BBRY in this way, and you should keep it in your mind. Otherwise, with the help of this trick, I think it is very simplest way. And then these are the numbers, significant numbers, and the multiplier should be, if it is 1, this is 10 to the power 1. If it is 2, 10 to the power 2. It is 3, 10 to the power 3, 4, 10 to the power 4, 5, 10 to the power 5, like this. And tolerance, next two things, that is silver and gold, and this has tolerance value or accuracy. If there is silver at the end, it has value 5% tolerance or accuracy, and if it is gold, it has 10% accuracy. Am I right? So let me take example, you can then understand. Say resistance is in this way. Color band or rings are given in this way. The gold is 5% and silver is 10%. So let us see if the resistors are, the resistance is having some ring of color or band of color. Say first one is, this one is yellow, and this one is violet, and this one is brown, and the last one is gold. The rule is, say this is A, B, C, D. Am I right? If the colors are given in this way, so at the end you will get either silver or gold. This is resistance, this is the accuracy, the percent is fixed. At the end is always. And if the end there is no color band is there or color ring is there, then no color, then it is 20% accuracy. If there is color, last color is gold, it is 5%, and if it is silver, it is 10%. Now how to write? Right, the style of writing is AB into C plus D percentage. Let us try to write how we will find out the resistance with the help of color code or color band or color ring. So for Y yellow, the first two is significant figure. You will give number 2, 3, 4, 5, 6 as this. AB, one is yellow, other is violet. What is yellow? Yellow, the value is 4. The yellow, the value is 4. And what is violet? Violet is 7. So this is AB, this is significant figure, and these are multiplier. C is multiplier, AB, C, brown is multiplier. Always first two is number 2, 3, 4, 5, 6, and third one is power, 10 to the power, means 0. How many zeros are there? Multiplier. So that C, ABC is brown. Now what is brown? For brown, you go to B, it is 1. The multiplier, that was multiplier, and this is significant figure, is 10 to the power 1. 10 to the power, first one is 0, 10 to the power 1. Sorry, it is given already, 10 to the power 1. That is your ohm. That is ohm. This ohm. Plus minus D. D is your tolerance. That is accuracy. And here it is given gold. Accuracy of gold is 5%. That is 5%. So this is the value of resistance of this type of color code or color band or color ring. And if you are asked to find out the resistance, if the colors are given, so you do in this way. Let me take another example. This is red, 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 and this is silver. So A, B, C, D. First two AV into C plus D percentage. AB should be your significant. First two, what about the color? First two is the significant, is the value, only value. And third one is the power, is the decimal multiplier. And last one is the tolerance or preciseness or accuracy. So your first two is red, red. What is red? Red is 2. So first two is 2 and second one is 2. These are significant figure. So third one again is red. For third red, you go to this value, multiplier, 10 to the power 2. Am I right? This is your ohm. Plus minus D, tolerance. What is silver? Silver is your 10%. It is this. So the resistance with color band RRR and silver has resistance 22 into 10 to the power 10 square ohm plus minus 10 inverse. Let me take another last example. I have not drawn the color band or color ring. The resistance is colored with, first one is say A, B, C, D. So first one orange, O-R-A-N-G, orange. Second one is blue color, next is yellow and gold. So first will give you significant figure. What is orange? Orange is 3. Am I right? And next one is blue. What is blue? Blue is 6. So 3 into 6. So AB into C is multiplier. What is C here? Yellow. What is yellow? Yellow. Its multiplier is 10 to the power 4. It is 10 to the power 4. And here this ohm, and here D is the tolerance. Here D is the gold. Gold is 5%. I have it. So this is the way how you are to calculate the value of the resistance from color code or color band with the help of the values which you should be kept in your mind. It should be kept in your mind. B.B. Royce, Gray Block, Vanished, Great Wrestler. So again I am writing B.B. Royce, Grave, Block, Vanished, Great Wrestler. So in this way B, and from 0 1 to you arrange and you multiply it in this way, and for the gold it is 5%, for silver it is 10%, and if no fourth one, if it is not given, you are to give here 20%. Am I right? So thanks a lot for watching the class. Hope in the next class I will start with new concept.